Let's start with sequences and series. So there are three types of sequences and there are three types of series. First is arithmetic progression, which is also called AP. Then there is geometric progression called GP. Then there is harmonic progression, that is called HP. So first we are going to learn about AP. For an AP, A plus D, A plus 2D, and like these terms like these, A plus n minus 1D is an AP. Why is it an AP? Because there is a common difference between two adjacent terms. Okay, like the difference between these and these is D. Difference between these two is also D, and these two will also be D, and these two will also be D. So this is a common difference. So that's why this series is called, this sequence is called an AP. Now let A be the first term and D be the common difference, then this series we'll have this series. So nth term of this AP, this is the first term, this is second term, this is third term, this is nth term. So the nth term, the formula for nth term will be A plus n minus 1 into D. If you put n is equals to 2, you will get the second term. Okay. Now the sum of these first terms of an AP, formula for the sum of first n terms of an AP, okay, this AP, it will be, the sum will be n by 2, let's denote it by Sn, n by 2, 2a plus n minus 1 into D. Okay, or you can write it like n by 2 a plus nth term, that is an. Fine, because an is a plus n minus 1 into D, that a and this a will become 2a. Okay, so this is the nth term. The rth term of an AP when sum of first r terms is given. So the rth term, let's say this rth term of an AP when SR and SR minus 1 is given to you, it will be, rth term will be, let's say TR, rth term will be SR minus SR minus 1, because SR will be, let's say 2, second term, T2 will be A plus D plus A, this is the first term, this is the second term, so the sum up to second term is this, minus the sum up to first term is A, so this will give you A plus D, which is the second term. That's how we get TR is equals to SR minus 1. This is an important formula, you need to remember this. Now we'll move on to properties of an AP. Let's first see some examples of an AP. This is an example of AP. Okay, up to infinity is an example of AP, because the common difference is 0, which is same everywhere. This is 0, difference is 0, their difference is 0, their difference is 0. So it's always a constant difference. So it's an AP. Again, like minus 2, minus 1, 0, 1, 2, 3, 4. This is also an AP, because the difference is 1. Okay. This difference is also 1. This difference is also 1. This difference is also 1. Okay. Now, these type of series are called an AP. Now, properties of an AP, that whenever a question come about an AP, what you have to do. So the first property is that if A, B, C are in AP, if let's say A, B and C, these are in AP, this means B minus A is equals to C minus B, because this is the difference and difference should be same in case of an AP. So if this is the condition, then this should be true. For this to be true, 2B is equals to A plus C. So the middle term is always the sum of, twice the middle term is always the sum of A and C. That is the first and the adjacent term. Okay. And if let's say A, B, C, D are in AP, A, B, C, D are in AP, then A plus D will always be equals to B plus C. This is the theorem, because let's say you can write B as A plus D, C as A plus 2D, and D as A plus 3D. It can always be written in this form. Let's say D dash, because we are using D here. So this can be written in A is A. Now add A and D. The LHS will become 2A plus 3D dash, right? And the RHS B plus C will become 2A plus D plus 2D dash, 3D dash. So this is always equal, okay? It does not depend on what is the value of D dash or what is the value of A. Okay. It is always the same. The second property about this is that three numbers are in AP if you are given that three numbers are in AP. This given to you, then you can always choose these three numbers, A minus D, A plus D, because these three numbers are in AP. If you are given four numbers are in AP, now you can choose A minus 3D, A minus D, A plus D, and A plus 2D. A plus 3D, sorry. A plus 3D. Fine. Now, if you are given 5 numbers are in AP, then for 5, you can choose A minus 2D, A minus D, A plus D, and A plus 2D. These 5 numbers you can choose because they show some same properties. Okay. You can easily evolve A and D from here if you use these 3 and these 4 and these 5. Okay. For 6, you can use A minus 5D, A minus 3D. I think you got the concept. A minus D, A plus D,